Good afternoon, ladies and gentlemen, and welcome back to the Royal Society for the first in our, let me be optimistic, our spring series of lunchtime talks. It's marvellous to have you all here and to have a full room and to have Patricia Fara to kick us off. Patricia's a senior tutor and director of studies in history of science at Clare College, and a paid-up historian of science who came to history of science out of conviction there were interesting questions that needed this sort of approach, which I think is much the best way to get to it, and has then devoted her professional life subsequently to, I was going to say answering, or at least tackling these interesting questions. I think one of the most ambitious books of recent times in history of science is her Science, a 4,000-year history, published a couple of years ago. Ambitious both because it says that science has a 4,000-year history, which I think is a striking statement in itself, and second, that it can fit inside one book, which I think is really marvellous. So I do commend that to you. That's not her subject today, though. Her subject today is women in science, and among her work on that is the splendidly titled Pandora's Breaches, Women, Science and Power. I think that's a brilliant title, and that will lead us into this afternoon. And also a book aimed at a slightly younger audience called Scientists Anonymous, great stories of women in science. So Patricia's really well qualified to talk to us today about her subject. It's a great subject, a great talk.
Thank you very much for that very generous introduction, and thank you to everybody for coming. And I'm going to start by explaining why I chose this rather odd title. It's based on this picture I found of the Cavendish Laboratory at Cambridge in 1900. And you can see most of the people here are men. I mean, it's rather odd for me to think that that's what undergraduates used to look like 100 years ago, because they certainly don't now. But there's also this woman, and the more I look at the picture, the more I'm mystified, because she looks like a cardboard cutout, and she's somehow standing in front of a mirror or a door as though she's been pasted in. So and the whole picture is rather sort of shadowy and ghostly. So that was the source of the rather enigmatic title. And women had been allowed in the Cavendish Laboratory for about 10 years by then, but where a lot of them chose to go was to either Girton or Newnham. And this is the scientific laboratory at Girton. You can see it's very different from the Cavendish. It's very light and airy. And these women are certainly very serious, working hard, and there's absolutely nothing ghostly about them at all. Of course, the male undergraduates weren't terribly enthusiastic about the women who arrived at Girton in 1869. And this is a piece of verse from Punch. The woman of the future, she'll be deeply read, that's certain, with all the education gained at Newnham and Girton. She'll puzzle men in algebra with horrible quadratics, dynamics and the mysteries of higher mathematics. So I think this verse is very interesting. Obviously, most obviously, it's ridiculing women. It's expressing that thought that a lot of people still have today, that you can't be both a normal woman and a good scientist. If you're a good scientist, you must be an abnormal woman. And I think that still, unfortunately, colours people's impressions of women who go into science. But I think it's also interesting because I think it expresses great fear. I mean, the men are rather nervous that these women arriving might turn out to be better than them at maths, and which is, in fact, what happened. And, I mean, not all the women, but some of the women were better than a lot of the men. And I'm going to talk in particular with this woman, Hertha Ayrton, who was one of the first undergraduates at Girton. And she came out with still, I think, one of my favourite statements about women in science. I don't agree with sex being brought into science at all. The idea of woman and science is completely irrelevant. Either a woman is a good scientist or she is not. And I think, unfortunately, that's a statement which still resonates today, in that I don't think we've quite achieved this ideal that she's putting forward. I'll tell you a little bit about her. She was great friends with this woman, who was 13 years younger than Hertha Ayrton. This is Hertha Ayrton, and the woman on the right, of course, is Marie Curie. Marie Curie, as you know, won 2 Nobel Prizes. This year, 2011, is the year of chemistry, and that's because it's the 100th anniversary of her second Nobel Prize, which she gained in chemistry. The previous one was in physics. So despite all these accolades and honours, this was how she was seen in an English journal, Vanity Fair, in a series called Men of the Year. And you can see she's here with her husband, Pierre. And I think it's very interesting because he's holding the radium that they discovered together. It was her research project. He moved in with her because he was so impressed by the research that she was doing. And it's all shining out on his forehead as though he's got the aura of genius. And she's peering over his shoulder behind him, looking rather dowdy and anxious. So I think it's sort of quite obvious that in those days, certainly, people in England could not credit that it was perhaps a woman rather than the man who deserved the reward for this great discovery. So, and when Marie Curie came over to England, she stayed with this woman, Hertha Ayrton. I'll tell you a bit more about her. She wrote this book on the electric arc. It came out in 1902. It was technologically a very important book in that it was used for making street lights work more effectively without spluttering and sparking. And I've written here a summary of her career. So in 1881, she gained a certificate in maths at Cambridge. Of course, no women were allowed to graduate until 1948. And that's why she's got what's called a certificate, although it was the equivalent of a degree. She left Cambridge, she got married. A few years later, she was the first female member of the Institute of Electrical Engineers. And you can see at the bottom that in 1906, she was the 5th person to win the Hughes Medal at the Royal Society, and that was for her work on electricity and magnetism. You can see in 1902, she was proposed for fellowship of this society. And the reason that she was turned down was that she was married. It wasn't that she was a woman, but that she was married. But at least she had been proposed for fellowship, and she had been allowed to present her own research inside the Royal Society. In contrast, this woman, Mary Somerville, after whom Somerville College at Oxford is named, in 1826, she had a paper in the Philosophical Transactions also about electricity and magnetism, but she wasn't allowed in the Royal Society to give her own talk because women weren't allowed in. So instead, her husband, who was a doctor and didn't really know anything about her technical research, had to give the paper on her behalf. When you were coming in, some of you may have seen in the foyer of the Royal Society, there's this bust of Mary Somerville. And although I'm sure the fellows at the time intended that as a tribute to her, it always rather annoys me because it seems rather hypocritical to put the marble bust in the hallway, but then not allow her in to give her own presentation. So I'm a historian of science, as Peter said, and I've sort of thought quite a lot about how we should write about women in science in the past. And the conclusion I came to was that we shouldn't just focus on the women. We should focus on how we think about history more generally. And we should ask ourselves some questions about what's important in the past. How is it that science has become so important in modern society? And so in the course of this lecture, I'm going to ask a few questions and think about different ways of answering them. And the first question I'm going to ask is science's history just about great ideas? If you pick up a standard old-fashioned sort of history textbook, it's just as though the torch of genius is being passed from one to the other. You've got great men, you've got Copernicus, Galileo, Kepler, Newton, Darwin, and Einstein, and on and on. The most famous, I think, of these great men is probably Newton, who allegedly sat under the apple tree, had a flash of inspiration, and hey presto, the theory of gravity was born. That version of history conceals all the hard work and the hard research that he himself put into his work on gravity. it also completely disguises the way in which his ideas about gravity became known throughout the world. Isaac Newton himself was an absolutely lousy lecturer. None of the students liked his lectures at all. He intentionally wrote his books using very complicated maths and all in Latin because he said, I don't want to interest the little smatterers in mathematics. So as far as he was concerned, just working out the theories was fine. But of course, in terms of the development of science, that's not much use at all. You need people who are going to spread the ideas. And when you start thinking about the growth of science in that way, then women come to play a much more prominent position. And this woman, Emilie du Châtelet, I think is probably my greatest heroine of the past. She's the woman I would most like to meet. You can see she's carrying the dividers. They're the traditional symbol of natural philosophers and mathematicians. She was incredibly clever. She could speak 6 languages by the time she was 12. And when she was in her 20s, she hired tutors to teach her mathematics and Newtonian physics, because, of course, she wasn't allowed to go to university. But I said earlier there's this sort of prevalent idea that good scientists must be abnormal women. And one of the things I like about her is that as well as being incredibly clever and incredibly hardworking, she also enjoyed wearing nice clothes, going to parties, dancing. She was very good at gambling, and that's one of the great advantages of being good at maths, is that you can finance your lifestyle at the gambling tables. And she wrote that she thought the most important thing in life was to be happy, was to get pleasure. And by getting pleasure, she meant not just partying and eating and going out with men, and she certainly did a lot of all of those, but also pleasure in intellectual work. So she approached everything she did with great intensity and great enthusiasm. And for about 15 years, she lived with this man, Voltaire. He was a political refugee, and she accommodated him in the chateau that her husband had given her. And then they lived together, and the husband was incredibly understanding and accommodating about this arrangement, and even though she had 2 children by him. So Voltaire and Emilie du Châtelet lived in the chateau, and from time to time, the husband, the Marquis, would come along and visit them. So Voltaire said she was a great man whose only fault was being a woman. And I think she's paid the penalty for being a woman twice over. First of all, she couldn't go to university, so she was absolutely desperate for education. Luckily for her, she had enough money to pay for it. She also, I think, in terms of posterity, she's too often cast as Voltaire's mistress, rather than being a woman in her own right. And so I want to introduce a slightly different way of looking at her. Until the roughly 1730s, even though Newton's book on gravity was published in 1687, most natural philosophers in France still followed René Descartes, who was the French national hero. And the French nation, in a way, was converted to Newtonianism in the 1730s, 1740s. And one of the key books that did that is often said to be this small book, Elements of Newton's Philosophy. And you can see it's got Voltaire's name on the title page, nobody else's name. But this is the frontispiece, and Voltaire commissioned it, and that pays far greater tribute to Emilie du Châtelet's contribution, which was undoubtedly substantial. So here we've got Voltaire, dressed up like a Roman with a laurel wreath, and he's busy writing. And up here, we've got somebody who's either Newton or God. It's a bit difficult to tell which at this stage. But he's either Newton or God up on a cloud. And here's the light of truth. And it's falling on this mirror. And the goddess is holding her mirror of truth. And the goddess in this case is Emilie du Châtelet. And the Newtonian wisdom is being cast down, reflected onto Voltaire, who is writing it down. And he wrote to one of his friends, Minerva, Emilie du Châtelet, Minerva dictated and I wrote. So he did pay tribute to her. And after this book was published, he went on and wrote lots of essays and plays and poetry that made him very famous. And she dedicated the rest of her life to carrying out scientific research and writing scientific books. And in particular, she decided to translate Newton's book, Principia Mathematica, in to French, and it's still the only complete French translation. When she set about translating it, she didn't mean just translating the words from one language to another. She went back to the original Latin, because she said the English translation had lots of mistakes in it. So she translated from Latin to French. But in addition to that, she explained what the mathematics meant, and she also criticised Newton if she thought he'd got something wrong. And as another form of interpretation of translation, she collected together all the experiments that had been done on Newton's physics during the last 20 or 30 years, and published those and commented on them and had them as footnotes. So it was far more than just a simple word-for-word translation. It was an extended commentary on Isaac Newton's physics. And without books like that, Newtonian physics would never have spread around the world or around Europe as quickly as it did. And in a way, she's the French equivalent of Mary Somerville, who lived 100 years later. There's Emilie du Châtelet with Newton's Principia, and one of Mary Somerville's translations was The Mechanism of the Heavens by Laplace. And Laplace liked to think of himself as the French Newton. And like Emilie du Châtelet, she didn't just translate the French into English. She was a very gifted mathematician, and she explained all the equations. And her version of The Mechanism of the Heavens became a textbook for university students and for a lot of practicing scientists, because at this stage, in the 1830s, English scientists were not particularly keen on the French methods of calculus. So she had to explain those as well. So there's this sort of double role of interpretation and translation. And if you think about the rise of science in that way, then women come to have a far more dominant role than in conventional histories of science. Well, the next question I'm going to ask is, did the men do all the work? And there are absolutely no prizes for guessing what my answer to that question is. So I'll just give you one of my favourite examples. It's Antoine and Marie Lavoisier. Antoine Lavoisier was the self-styled revolutionary chemist at the end of the 18th century, literally revolutionary. He lost his head. He was guillotined. And he's sitting here writing his big book on chemistry, in which he introduced the chemical symbols that we've got today, like Fe for iron or S for sulfur, and the idea of balanced equations, which we have, which is still very important in modern chemistry. And you can see from all this apparatus around him that he thought it was very, very important to carry out very precise experiments. He was terribly keen on measuring and making the two sides of an equation balance. And this is his half of the picture. This picture is in the Metropolitan in New York. It's sort of almost as high as this room. It's a huge, stunning picture. And this is her side. So he's gazing up at her as though he's very devoted to her, and she's leaning fondly on his shoulder, looking as though she stepped straight out of the bathroom and hasn't thought about anything. But if you look here, this is a portfolio of her drawings, and she studied painting and drawing under David. David was the artist who painted this picture. And if you look at her drawings, you get a very different view of how scientific research was carried out. Rather than Lavoisier being the sole discoverer, you can see him here. He's more like a stage director. And this poor guy, for example, is doing a lot of work, and so is this one. He's got rubber suits and taffeta masks, and he's treadling away under there, and they're measuring all the oxygen and carbon dioxide as it goes in and out. And here's Madame Lavoisier, not in the bathroom getting ready, but in the laboratory, taking notes. And if you look at Lavoisier's notebooks, it's got her handwriting all over them. She clearly organised all the laboratory supplies, and she is there writing down the results. So she's right in the middle of this experimental cooperative space. When they got married, she was only 13 years old. And the first thing that she did was to learn English. He never learnt English. And a lot of the important chemical work was being carried out by people like Priestley. So again, she translated from English to French into English. She travelled with him to all the factories and was very involved in all the research that he was doing. And there's 12 plates like this in his textbook. And you can see there's a scale at the bottom. And I mentioned the importance of precise experimental measurement. And the idea of the book was, and the plates, was that this book could go out anywhere in the world, and wherever you were, in London or in Berlin or New York, you could rebuild exactly the same apparatus as Lavoisier himself. And you all know who drew the plates. And her original sketches and her drawings and her measurements and corrections are all preserved at Cornell University in America. So again, although her name wasn't on the title page, she provided the 12 plates of illustrations, which were an absolutely vital part of Lavoisier's book and absolutely crucial for disseminating his ideas. So as another example of did the men do all the work, I'm going to go back to Mary Somerville, and this man here is Charles Lyell, the geologist, who was one of her close friends. And 19th century women tended to live in a sort of scientific network, a bit like a scientific dynasty. And men often married the daughters or the sisters of famous scientists because they could be confident that the women had been carefully trained up by the fathers or the brothers, and so would be useful for them in their own research. And that's exactly what Charles Lyell did. He's most famous for this book, Principles of Geology. And this is on their honeymoon. Their honeymoon turned into a field trip, and this is a temple of Serapis at Naples, and you can see these dark patches here are where marine organisms have bored into the columns. And Lyell used this as evidence that the water, which you can see here, has gone up and down and up and down. So it suggests a very, very long history of the world in which slow changes have been taking place at the same rate in the past as they are today. And this is a book that Darwin took with him on his voyage on the Beagle and provided an extended history of the universe which made evolution seem possible. So he married this woman, Mary Horner Lyell. When I looked on Google Images for a picture of Mary Lyell, all I got was pictures of him. And I was so annoyed that I decided I would just use this silhouette to represent her. She's like lots of other women. This is really quite difficult to find. You just have to look sort of in the margins of historical records to find evidence of how active these women were. And Lyell, when they were engaged, Lyell wrote to her, "Had our friend Mrs. Somerville been married to a mathematician," she was married to a doctor, as I said, "we should never have heard of her work. She would have merged it with her husband's and passed it off as his." And that is exactly what happened to Mary Lyell. And it's also what happened to Mary Buckland, who was also married to a geologist. And there's a display case that the library has prepared showing some of the archives at the Royal Society connected with women in science. And there's some of the marvellous drawings of fossils that Mary Buckland did. So Mary Lyell, after she was married to him, rather like Marie Lavoisier, she learnt German. Lyell was very short-sighted, so she sat in the evenings reading to him. She edited all his manuscripts. She organised all his collections, and in particular, she was in charge of his shell collection. And shells, in a time when evolution was being debated, shells were obviously a very important part of scientific research. And this is what she wrote to her friend. "I have taught Antonia," there's Mary Lyell and there's Antonia, because I have no idea what they look like. "I have taught Antonia to kill snails and clean out the shells, and she is very expert." So Mary Lyell is another excellent example of someone who received no formal credit whatsoever, but was responsible for a lot of the work that was credited to her famous husband. And these two women, Antonia and Mary, are just two representatives of thousands and thousands of women about whom we know very little, but who were carrying out a substantial amount of scientific work during the 18th and 19th centuries. Mary Somerville, in a way, was one of them. She wrote, "I hid my papers as soon as the bell announced a visitor, lest anyone should discover my secret. So these women were embarrassed about what they were doing. They felt they shouldn't be carrying out scientific work. And so it's sort of, in a way, hardly surprising that we know very little about them, because they deliberately kept themselves secret. Even someone like Mary Somerville, who became celebrated as the Queen of the Sciences by the end of the 19th century. So my next question is one I've raised before. Can female scientists be normal women? And I think this idea that they can't has got a very long history. So I'm going to go back to the very beginning of the 19th century. This is one of my favourite pictures. It's called A Lady of Scientific Habits. And you can see she's constructed entirely of books. And there's a lot of terrible puns, like this is called Handel and Army Notes. There's a pun on hand and arm. But it was a real book. And it just offers a terrible warning to women. If you take on science, if you dedicate yourself to academic work, you're going to become as dry and dusty and sterile as a collection of books. And this is another picture from the same period. It's the frontispiece of an encyclopedia. And it shows another rather unusual woman, the goddess of wisdom, Minerva. And you can tell it's her because she's got an owl on the top of her helmet. But you can see she doesn't look like a normal woman, I mean, apart from the fact she's wearing a helmet. But she's very big and muscular, so she's sort of rather androgynous. And she's pulling back the curtain on the books. But the only person who's going to read those books is a man. And here's a student interrupted in the course of his study. And another book from, again, around the same period, end of the 18th century, is Mary Wollstonecraft's A Vindication of the Rights of Women. Mary Wollstonecraft is often said to be the first feminist. When you read this book, it is nothing like the sort of feminist campaigns that we saw in Britain in the 1960s and 70s. Mary Wollstonecraft, like so many of these women, was not campaigning for equality. She was campaigning for women to be educated, but the reason she wanted women to be educated was so that they could look after their husbands better, because they would be interesting to talk to, and because they would give their children, especially the boys, a better education. So at the end of the 18th, early 19th century, there was not a feeling amongst either women or men that women were the equals of men. Both sexes thought that they should have different roles within society. And I think, although we certainly believe in equality now, I think that sort of attitude, that feeling, still unfortunately survives. So I'm going to give you two examples of 20th century women and sort of discuss how they were not perceived as ordinary women, as they were perceived as being rather abnormal. And the first is Rosalind Franklin, who she did her degree at Cambridge, but she couldn't graduate because it was slightly a few years before 1948. After graduation, she went off to France, to Paris, and she carried out some research. She was very happy. There were no problems whatsoever. And then she came back to London, to King's College, and she was doing research into DNA. She was a very systematic, methodological researcher, which is one of the ideologies of how scientific research should be carried out. And she took this photograph, which, if you know what you're looking for, apparently immediately signifies that the structure of DNA is a helix. So she took this photograph and she filed it away because she was working through all her photographs very systematically, and this belonged to something she called Series B, and she was working on Series A. Unknown to her, James Watson came on a visit from Cambridge, and was shown this photograph. There's a great controversy, which I won't venture into, about how he saw the photograph, but he did see it. And the minute he saw it, he realised its significance, and he went racing back to Cambridge, and he got his friend Francis Crick, who had already spent years doing a PhD on something different, but never quite got around to doing it. And they worked furiously for the next few months and came up with the structure of DNA. And this is the most famous publicity photograph. I saw there's a copy of this or a similar one downstairs. Crick and Watson had a totally different approach to doing science from Rosalind Franklin, particularly Watson. And he made it clear a few years later in this book, The Double Helix, when Watson's view of doing science is that science is very competitive. You take every shortcut you possibly can in order to get to the answer quickest. And he also minimized the amount of work that he did. If you read his book and believed him, you'd think that he spent most of his time playing tennis and chasing women. I'm sure he did do both of those, but I imagine he also did a lot of very solid research, which is what you have to do if you're doing science. You would have thought also that he would have paid tribute to the woman who took the photograph that enabled him to sort of fast forward and short-circuit a lot of other research to get to DNA as a double helix, but he didn't. He was very, very insulting to her. She did not emphasize her feminine qualities. There was never lipstick to contrast with her straight dark hair, while at the age of 31, her dresses showed all the imagination of English blue-stocking adolescents. That might and might not have been true, but it's completely irrelevant as to whether she's good at doing science. But it's also a perpetuation of this idea that because she was a good scientist, she definitely was a rather abnormal, freakish sort of woman. The next example I'm going to give is of a woman who's still alive and a Fellow of the Royal Society, Jocelyn Burnell. And I'm using this as an example of how, as a woman, a very distinguished woman, she perceives women in science. This photo was taken in the early 60s. She did research at Cambridge into pulsars. And she reports on experiencing a great deal of discrimination at the time. So, for example, when she got engaged, she didn't wear her engagement ring into the laboratory. She took it off every morning because she knew that if she went in with she felt that if she went in with an engagement ring on, the discrimination against her would be even greater than it was already. And in her opinion, this is what she said fairly recently, as a woman in physics, you certainly need to be a superwoman. So there we have a man, Watson, and a woman, both saying the same thing fairly recently, that scientific women have to be slightly abnormal. Well, I don't want to finish on too gloomy a note, so my last question is change possible? And I'm going to give an example to illustrate why I definitely think that it is. And I think science has changed a lot already, but I think things will only get better. And the example I'm going to give is of Caroline and William Herschel. They were both astronomers, and in the showcase, there's an example of a letter from Caroline Herschel. She was the first woman to discover a comet, and she discovered several comets, and her papers were printed in the Philosophical Transactions of the Royal Society, although, of course, like Mary Somerville, she was never allowed to enter into the Royal Society herself. And her brother was an astronomer. They were born in Germany, and he came over here and settled in Bath. And she wanted to be an opera singer. And her mother was very reluctant to let her leave Germany because her mother wanted her to stay at home and look after all the rest of the children and the father. But William eventually managed to get her out of Germany and over here, and she started off her career as a singer. And then he became more and more interested in astronomy, so that was the end of her singing career. And he gave her lessons in astronomy over breakfast and forced her to help him. And he discovered the planet Uranus, and he also discovered lots of nebulae and stars. And you can see a model up there of his giant telescope. This is a 19th century imaginary picture reconstructing their lives together. So he's polishing a mirror, and she is bringing him a cup of tea. And when I first saw this picture, I was absolutely horrified. I thought, this is terrible. This is so typical, showing the man doing all the work while all she can do is bring the cup of tea. And then I saw this little box at the bottom with this woman, this doll peering out. I thought, aha, that's a symbol of her trying to escape her life. But I realised, after I started reading her autobiography, I realised that I was bringing very modern preconceptions to their life together. If you read what she herself says, the picture is, in a way, is representing reality. Since by way of keeping him alive, I was constantly obliged to feed him by putting the victuals by bits in his mouth, serving tea and supper without interrupting the work with which he was engaged. So, in that sense, the picture is telling the truth. She also, like many of the other women that I've talked about, she also had this idea that she was inferior. So, in a way, she colluded in her own oppression. She wrote, "I am nothing. I have done nothing. A well-trained puppy dog would have done as much." In fact, she did a huge amount, because if you think about taking an observation with a telescope, you need, especially a giant telescope, like that, you need one person, you can't see it, but it goes on up there, you need one person at the top of the telescope and one at the bottom to write the reading down, and then you need somebody who's going to transform all the data into a form in which it can be recorded, and then you need someone to catalogue all the stars, and that's exactly what she was doing, and I think that's a far more important contribution than her work on comets. So she was doing a huge amount, but she saw herself as totally inferior. So why do I think it can lead to change? The woman who edited Caroline Herschel's autobiography was a woman called Constance Herschel, and she was William's granddaughter. So she published the autobiography, and she was a lecturer at Girton Laboratory. This is a picture I showed you before. And at Girton Laboratory, one of her students was Hertha Ayrton. So there's 100 years. There's 100 years between that picture and this picture, and there's 100 years between Hertha Ayrton's statement, which I mentioned earlier. I don't agree with sex being brought into science at all. The idea of woman in science is completely irrelevant. Either a woman is a good scientist or she is not. I think there's been huge change in the last 100 years. Every year, women fellows are appointed to the Royal Society. Whether they're married or not seems now completely irrelevant. But so I see this as this sort of family connection as a symbol of how things will improve in the future. So that's the end of the formal talk. But if you'd like to ask me questions, I'd be very glad to answer them.